Okay, welcome back. So in the last video, we took a look at some really basic history of web servers and how some current companies are utilizing these amazing changes in web server and computing technology to build better, more interesting, and really building businesses that couldn't exist even 10 years ago. So before we move any further into web servers and the actual management and administration of web servers, we need to have a little primer on exactly how a web server works and what's happening when we type a URL into a browser window. So the first thing that happens when we access a web page is we go to our computer, we open up a browser, and we type a URL. And in this example here, we type google.com or http://google.com. And what happens is when we type that name into that URL into our browser, the web server really doesn't know what that means. In fact, the browser doesn't even really know where the web server exists. All this is a name with no real information attached to it. So what we have to deal with this is called the domain name system. And essentially there are servers out in the world that take incoming names, domain names like google.com, and translate them into IP addresses. And IP addresses are how we actually communicate with servers and with computers. So when you install a new server in your dorm room, that server is, or a new computer, that computer is assigned an IP address. Now, in the case of Michigan State, that IP address might change. It might be dynamic, but it's still an IP address. Your computer is specifically accessible at that address. So the first step in accessing a web page is getting our domain name translated into an IP address. So once we've done that, once our browser has the IP address, then the browser can go request files from that IP address. And so what is issued is essentially what's called a GET request, because we just want to read and pull files from the server. And so our computer issues a GET request for a specific set of documents. In this case, since we're just accessing google.com, we're accessing the index file of the Google web server. So we're essentially just getting the index file. So Google responds to that by sending us the index.html file and any other files that may be associated with that. So if there's images embedded in the HTML, those images will download and come along as well, along with style sheets and JavaScript or anything else that needs to come along with that request. Once that request is complete, we stop talking to the web server. It's a stateless connection. There's no continuing connection with the server. We go out to the server, make a request. The server processes the request, sends the documents back to us, and we don't talk to the server again until we need a new page. The server is then free to go on and talk to other clients and send them the documents that they need. So we are actually downloading these documents onto our own machines to read. And we'll get into this later, but this is one of the ways that we can serve lots and lots and lots of static files like this through web servers is because the connection is not persistent. The connection is closed, and the server is free to then go talk to other clients. So most of the work we're going to be doing in this class, and most of the modern kind of web server infrastructure or web server stack, as I like to call it, or as it's also referred to, are based on these four major sections. And if you really want to get into the nitty-gritty, in each of these sections, web server, language support, operating system, hosting infrastructure, there might be sub-stacks within each of those things, and that gets a little complicated, so this is kind of abstracting that a little bit and looking at it from a higher level. So the first thing we have is our hosting infrastructure. So our operating system, our programming languages, and our actual web server software, they have to live on something. Our hosting infrastructure either needs to be a server in our basement or under our desk, or it needs to be a data center in Lansing, like with Liquid Web, or it needs to be some data center, in Texas with Rackspace. It has to be some kind of system. So the hosting infrastructure can be as simple as a server or a collection of servers in a hosting environment, all the way up to very, very complex cloud systems that actually allow us to kind of build and deploy virtual servers, which we'll talk about soon. So you have to have a hosting infrastructure. You have to have a place to install the operating system, install the language support, and install the web server. In our case, our hosting infrastructure is going to be Rackspace's cloud computing platform, or the Rackspace Cloud. So the next thing we have to consider is our operating system, because web servers are just pieces of software, and those pieces of software have to run on something. They have to run on an operating system. So in our case, most of our web servers are going to be running on the Linux operating system, specifically Ubuntu. And again, we'll get more into that later. But web servers could just as easily run on Windows operating systems and also on Mac OS X or Unix operating systems. And traditionally, most websites are hosted on a Unix type platform. So that's either BSD Unix or Linux, Ubuntu, Debian. There's all sorts of variations of Linux, but it's usually one of the two. You don't typically see a ton of Windows-based web servers, and that has a lot to do with Microsoft and a lot to do with kind of the open source nature of the web. Typically, system administrators, open source people gravitate more towards Linux and Mac OS X for operating systems as opposed to the more commercialized Windows. So just know that you can pretty much run a web server off any operating system. For this class and professionally, I would recommend Linux-based web servers unless there's a specific reason you need to go with Windows or some other operating system. So the next thing we need to worry about is language support. And what I mean by language support is a couple of different things. So we have to be able to run the web server on our operating system. So we need to make sure that the operating system supports the type of web server we're going to be running. Apache doesn't natively install onto Windows. It's a Unix-based application. So I believe there is an Apache port for Windows, but that's not a native application. So that Windows machine needs special language support and special drivers to run that web server. What I also mean by language support is our web server will need to be able to support scripting languages that are common in websites. And these are things like PHP, Ruby, Python, Perl. All of these types of languages need to have underlying support. So for example, if I had some PHP code in my website and I wanted my web server to be able to properly serve that file, there would have to be underlying language support for PHP. Otherwise, it's just going to print the PHP text and not actually compile it on the back end. So anytime a web server comes across code in a web page, like PHP, Ruby, or Python, the web server's got to send that down to the operating system or send that down to a lower level process to be compiled, processed, and then sent back up to the web server. Apache itself doesn't compile PHP or doesn't interpret PHP. PHP is not really a compiled language, but it does interpret it and send it down to the operating system for to be processed. So language support is important. You don't need to support all the languages. You just need to support the languages that you need for your site. So in a Ruby on Rails application, the only language support we probably need is the Ruby language support, because that's what Rails and subsequently all of the Rails technologies are built up on. And we'll get into this too, again, as we start building out your servers. We'll see how we can add different types of language support to Apache and to our operating system. So the last part of the stack, kind of the outward facing part of the stack, the part that we hit when we interface and interact with web servers is the web server itself. This is the installed piece of software that sits on our operating system, on our hosting infrastructure, that actually communicates with client requests. So it receives the requests from clients, figures out what they're asking for, and sends along the appropriate files. In this class, we're going to be primarily dealing with Apache, because for those of you that want to move into this type of administration as professional careers, you will most likely encounter Apache as your primary web server. Another web server we're going to take a look at in this class is Nginx, which is a Russian web server that functions a little bit differently than Apache. Nginx is what we call an event-based web server, whereas Apache is more of a process-based web server. And I'll get more into the details of those a little bit later on in the semester when we talk in detail about the different types of web servers. And we also have IIS, which is Windows, which is the Microsoft Windows, I think it's Internet Information Server, I believe is what IIS stands for. And that is the Windows variant of the of a web server, and this typically is used for .NET applications and essentially kind of Microsoft's commercially supported software can all run on IIS. So there are instances in where you would run into an IIS server. So knowing that and having all that, the other three main things that we kind of need to worry about in this class in terms of dealing with that stack. So, we have this stack here. How do we get access to that? How do we deal with this at an actual practical level? And so there's a couple tools that we have at our disposal to do that. First and foremost is our terminal window, or SSH, which I'll talk about here in a second. And this allows us to actually gain access to our server. Most of the web servers out there, do not have monitors attached to them. They don't even really have graphics cards. We SSH into them, or we connect to the servers remotely, and we operate them by issuing the server commands to do specific things. And we also control them by editing text files, which are essentially configuration parameters for the server. And we'll get into that later. You will become really comfortable working in the terminal in this class, because that is primarily where you will be spending most of your time. The second bit of software that we'll commonly use is an FTP client. In this case, I like Transmit. That's the Transmit logo you see right there, and that is a Mac-based FTP client. There are plenty of other ones out there, and in the show notes below, you'll see links to other FTP clients that are both free and commercially available. I specifically say SFTP in this because that stands for Secure File Transfer Protocol. FTP, without the S, is in and of itself fairly insecure. It sends things in plain text, including passwords, and is generally easily hackable by packet sniffing, and it's just not a great protocol. It's easy and very convenient. It's not very secure. SFTP, or Secure File Transfer Protocol, is actually the FTP protocol delivered over SSH. So it's fully encrypted end to end, and there's no risk of being kind of packet sniffed for plain text passwords. Just doesn't happen. And so finally, the other thing we need to make all this work is a web browser. It's really hard to access the internet and websites without a web browser, and in this class it's no exception. Firefox is commonly used, so is Chrome. I use Chrome for most of my examples in this class. You feel free to use Firefox or Chrome or Safari. I would encourage you not to use Internet Explorer, and this is a personal opinion of mine, but it tends to be the most buggy and the kind of the most prone to issues. If you stick with Firefox or Chrome, I think you will mitigate most of those issues. And this really is more important to the to my web design students in 349 because they'll have to deal with the weirdness of Internet Explorer a little bit more than 362. You guys will. But it's good to at least have a couple different browsers on your operating system or on your machine so that you can do some testing. And if something's being funky in Internet Explorer, you can hop on over to Firefox or Chrome and make sure it's not a browser issue and that it's something else. Okay. So like I said, we're going to be spending a lot of time in the terminal window in this class. And in the next video, I'm going to briefly give you guys an introduction to this, and we're going to talk a little bit about how we're going to be utilizing the terminal in this class. Also later on in these videos, you'll actually see me interacting with our Rackspace server through the terminal, and you'll get a chance to play around with that yourself as well. So we'll see you in the next video.